Exercise 2.3, Problem 5, Division 1, Discussion. Which term of the geometric sequence 5 to 4 by 5, 8 by 25 is 128 divided by 15,625? Okay, so let's mark. It's a geometric sequence. Okay, they have given T1, T2, T3, T4, and they have given the another term Tn. We don't know what it is. Okay, so I think this is basically the given information. So let's write it out. So A equal to 5, that is the first term, that is T1, T2 is 2, T3 is 4 by 5, T4 is 8 by 25, and it's a geometric sequence. So what are we asked to find? We are asked to find which term this 128 by 15,625 is. Okay, so actually I should write find n for 120 by 15,625. I'll correct it next time. Okay, but that's what we need to calculate. Okay, what is the term number Tn, the value of n, which term of the series is this number? Okay, the value of n for 128 by 15,625. Okay, now let's list out the formula. We know the formula for Tn, that is Tn equal to a to the power of r to the power of n minus 1. Tn is given here. Okay, the Tn is 128 by 15,625. A is known, but we cannot use this equation as of now because there are two unknowns. R is not known, n is not known. So n cannot be calculated unless we find out r. Next step, write the formula for r. R equal to T2 by T1. Both T2 and T1 are known, so which means r can be calculated. Once r is calculated, go back to this equation. Then you will be able to solve n. Okay, it's pretty simple, right? So let's write the steps. Let n be 128 by 15,625. Let it be the nth term. Okay, right. Calculate the common ratio using r equal to T2 by T1. They have given T2, they have given T1. T1 is a, right? So you'll be able to calculate r. Then substitute values of a, which is 5, r, which we calculated here, in the formula Tn equal to a r to the power of n minus 1, and equate it to this one, 128 by 15,625. So what will happen? You will get a r to a is a r to the power of n minus 1 equal to 128 by 15,625. And in this equation, everything is known except n. Only one unknown is there. So which means it can be calculated. Then solve this equation and get the value of n. Okay. So let's pause the video here and try to work this problem on your own, and after completion please come back and check your working against our solution. Okay, the solution. A equal to 5, T2 equal to 2, okay, T3 equal to 4 by 5, T4 is 8 by 25. So let Tn be 128 by 15,625. Calculate the common ratio, which is T2 by T1, that is T2 is 2 and T1 is a, that is 5. So it is 2 by 5 is your common ratio. And substitute the value of a, which is 5, and r, which is 2 by 5 calculated here in the equation Tn equal to a r to the power of n minus 1, and equate it to 128 by 15,625. So what happens, in the place of Tn you are putting 128 by 15,625. So this equation will become a r to the power of n minus 1, but a is 5. So 5 into r is 2 by 5. So 5 into 2 by 5 to the power of n minus 1 equal to 128 by 15,625. That's what you've written here. A into r, which is 2 by 5 to the power of n minus 1 equal to 128 equal to Tn, but in this case we are taking Tn as 128 by 15,625. Now, whenever there are two exponentials, we have to convert this into an exponential, okay? Or you have to take log. So let's convert this into an exponential. You have to write this in terms of 2 by 5. That's the key here. So this will be 5 into 2 by 5 to the power of n minus 1 will be equal to 128 is 2 to the power of 10. 15,625 is 5 to the power of 6. Check it yourself. Okay, 5 5s are 25, 25 5s are 125. Like that, you can check it out. multiply 5 6 times and see whether it is 15,625. Multiply 2 7 times and check whether it is 128. But we have checked, and that is what we are writing. It is 2 to the power of 7 by 5 to the power of 6. Now what will happen? Next step, 5 is here, it will come in the denominator. So this will become 5 to the power of 6 into 5. So that will become 5 to the power of 7. So next step will be 2 by 5 to the power of n minus 1 will be equal to 2 by 5, sorry, 2 to the power of 7 divided by 5 to the power of 7. But we want to write it in this form, right? Then we will be able to solve it. So this is equal to 2 to the power of 5 by to the power of n minus 1 equal to 2 by 5 to the power of 7. Okay, we are taking that commonly out. So now two exponents are equal. Their base, which is 2 by 5, is equal, which means the power also equal. So n minus 1 will be equal to 7. A to the power of x equal to a to the power of y. A is the base, x is the power. So there are two exponents, that is this whole thing equal to this. The bases are equal, a equal to a, which means x is equal to y. Similarly, 2 by 5 to the power of n minus 1 equal to 2 by 5 to the power of 7. So both the cases the base are equal. So this equals this. So which means this will be equal to this. That is, the power will be also equal. So n minus 1 equal to 7, or n equal to 7 plus 1, that's equal to 8. Thus 128 by 15,625 is the 8th term of the geometric sequence. Okay. So please check your working against the solution. If there is any error, please make suitable correction. If you have not understood the concept, please go back to the discussion part of the video and review it. Okay. Thanks for watching this video.